Today I'm here to present the fourth video lecture of the series of subject Digital Signal Processing BEC 503, and I am Dr. Amit Garg, Associate Professor in EC Department of Akgec. First, we will see what is linear convolution and what is circular convolution, and basically what is the difference between them. Okay, so convolution is basically an operation by which we can get the output of a linear time system. If we will talk about the linear convolution, you can simply call it as linear convolution, this operation which we have already seen in our subject signal system. But here another concept is there, which is circular convolution. So in case of circular convolution, the convolution operations remains the same, but here one of the sequence is the periodic sequence. At least one of the sequence is the periodic sequence. So let's see what is the difference. So in case of linear convolution, the length of the input sequences can be different. So let us suppose we are taking two sequences. One is, let's say, x1n equals to, let's say we are assuming it is 1, 2, 3. So this length of this x1n is nothing but 3. And another sequence, let's say we are taking as 2, 3. Then you will see the length of x2n will become 2 in this case. So here, if we want to calculate the linear convolution, then we can find out the linear convolution between these two sequences. But here in circular convolution, the length of input sequence should be the same. So we can apply the linear convolution on these two sequences, but circular convolution cannot be applied in its original form because you can see the length is different. So if we want that the circular convolution is computed, then we should add some zeros. We should add 1 0 so that the length of these two sequences will become same, and that is called as zero padding. That is our second point. So you can see here zero padding is not required, which we have already seen. We can directly find out the linear convolution between these two sequences. But here the case, if the length of the input sequences are different, then zero padding is required. So according to the second point, we require to add 1 0 pad in this sequence. Now you can apply the circular convolution between these two sequences. And the third point, the input sequences need not to be periodic. So the sequences that we are taking need not to be periodic. And in circular convolution, at least one of the input sequence should be periodic or extended. So here, if we want to calculate the circular convolution between these two sequences, then one of the sequence must be periodic. And the output sequence is non-periodic. Here, in case of linear convolution, the output sequence is not periodic. The sequence that we will get is not a periodic sequence. And if we will check in case of linear convolution, the sequence will be the periodic. The output sequence will be the periodic, and the periodicity is the same as that of the input sequence. Means, let's say if these two sequences both are having 3 elements, then the output will repeat itself after 3 values. Okay. And if you will see this linear convolution, then the length of the output sequence will become 3 plus 2 minus 1. This is the length of the, let's say, linear convolution. This is let's say length of x3n, which is nothing but our convolved sequence. So this is nothing but equal to 4. And in circular convolution, what is the length? Maximum of x1n comma x2n. So you can see the maximum value is 3. So length of x3n will become 3 while applying the circular convolution. So this is basically so you can say, based on this, the length of the output sequence will be greater than the length of the input sequence. You can see the length of the input sequence is here 3 and here 2, and the length of the output sequence is 4. And the length of the output sequence is same as that of the input sequence. Okay. So if we are applying circular convolution between x1n and x2n, then first we have to add one 0 over here. Only then we can compute the circular convolution. So that's why we can see in case of circular convolution, the length of the convolved sequence is equal to 3. So basically this is the difference between linear convolution and circular convolution. Now in this particular lecture, we will see that how circular convolution can be computed between two sequences. So there are basically three methods which are generally used. First one is graphical method or circle method. Second one is matrix multiplication method, and third one is DFT, IDFT or Stochamp's method. Okay. If you will see, then out of these three methods, the default method is the graphical method. If no method is mentioned in the question paper, then you have to solve the question using the graphical method. Matrix multiplication method is easier to solve. You can easily calculate it, but generally this question is not, this method is generally used for checking or verification of your answer. And last one is the DFT, IDFT method or Stochamp's method. This method is based on the computation of DFT and IDFT for the calculation of circular convolution. Okay. So let us start with the graphical method. Let us see one problem, that how we will solve the circular convolution between two sequences using graphical method. Okay. So let us suppose we are giving two sequences, 1, 1, 2, 2 and another one is 1, 2, 3, 4. Now we have to find out the circular convolution using the graphical method. Okay. So if you will see the expression is x3m equals to summation n equals to 0 to n minus 1 x1 n into x2 m minus 1 m minus n mod n, mod capital N, where m equals to 0 to n minus 1. So this mod n is basically showing the length of the periodicity. Means after 4, if n is, let's say, 4, then it means the sequence will be repeated after each 4 sequences. Okay. So you can also call you can check the values like x2 minus n mod 4 will become x2 minus n plus 4, that will become x2 4 minus n, and if you will put the values like n equals to 0, 1, 2, 3, then you can check then what is the values of reflection values. Okay, because you know the convolution operation consists of various operations, like first operation is the reflection operation, then reflection or folding operation, then you will basically do the shifting, and then you will multiply both the sequences, and then you will add it up. Okay, so this is basically the procedure how we will perform the convolution on two sequences. This the procedure is similar for both you can say circular convolution and linear convolution. But in circular convolution, what happened? One of the sequences of periodic nature. Here you can see both the sequences are periodic because they are repeating after 4th sample. Okay, so you can see x1 0. So now we will see first of all how we will solve it. Okay, so we will draw this sequence x1n, which is given to as 1, 1, 2, 2, and you can see the sequences are like x1 0, x1 1, x1 2 and x1 3, and the values are 1, 1, 2, 2, 1, 1, 2, 2. And similarly, your x2n sequence, which is given to us, is 1, 2, 3, 4. These values are 1, 2, 3, 4. Then, if let's say m equals to 0, then according to this expression, if m equals to 0, then expression will become x1n into x2 minus n mod n. Capital N is 4, so it will become mod 4. Okay, so now you have to find out x2 minus n mod 4. Only then you will multiply, then you can multiply it by x1n and then you will add it up. So what is the value of x2 minus n mod 4? So x2 minus n is simply you can see the reflection of this signal or the mirror image of this signal. Okay, so this value you can see this x2 0 and x2 3 values will remain same, and these two values get interchanged. How? You can see the value of x2 minus n mod 4, you have seen this value. Okay, so when n equals to 0, you are getting x2 minus 0 is x2 0, that's why this value will remain same. x2 minus 2 is equal to x2, this value is remain same. But what about the value of x2 minus 1 mod 4? This will become x2 3. And what is the value of x2 minus 3 mod 4? This will become x2 1. That's why these two values get interchanged in case of these two sequences. Okay. So now next step, we have to multiply these two values and add it up. Okay. So we are multiplying x1 0 with x2 0, means according to this folded sequence values, 1 into 1. So this value will become 1. You can see 4 into 1. So this value will become 4. 2 into 3. So this value becomes 6. 2 into 2. So this value becomes 4. Then you will add it up all these values. So this is 1 plus 4 plus 6 plus 4. So you will get the value 15. So this is how we will get the first value of the convolved sequence. Okay. Now come to the next slide. Now what we will do, we will shift the sequence. Let's say now this n will become 1, and we will shift this sequence by 1 in the anti-clockwise direction. Okay. So this will become x2 minus n plus 1. So you can see this in the next slide, x2 minus n plus 1 or x2 1 minus n mod 4. How you will get this value? You will shift this sequence by 1 unit. You will shift this sequence so that the values are 1, 4, 3, 2. Rather than you will get the values 4, 3, 2, 1. So the next values are so this value will become, this value will come here, this value will become here. You can see simply the 2 will come over here, 1 will come over here, 4 will come over here, 3 will come over here. So this you can see. Now again we will multiply x2 1 minus n, this sequence, with the corresponding values of x1n and add it up. So this is x1n into x2 1 minus n mod 4. You will get the values 2186. Then you will add this product sequence. So the value will become 2 plus 4 plus 8 plus 6. That is equal to 17. Now for m equals to 2, what you will do? You will do one shift of this folded sequence or two shifted of this folded sequence. So that again we will get the values 3, 2, 1, 4, and again you will multiply x2 2 minus n mod 4 with this one. With this one, okay, so that you will get these values, and you will add it up. So again you are getting the value 15. And similarly, one last time, for m equals to 3, you will again shift this by 1 unit, and you will get this circle, and the corresponding elements of this circle can be multiplied with this circle values, so that you will get the values x1n into x2 3 minus n mod 4. Then you will add it up. So the values are 4 plus 3 plus 4 plus 2, that will become 30. So now here this is how we have calculated the value of convolved sequence. So the first value is your 15 that we have obtained for x30, 15, then 17, this one, and then 15, and then 30. So these are 4 values which is used, which is basically the convolved sequence. Okay. So this is basically the first method, which is called graphical method. The second method is matrix multiplication method, which is you can say a simple method. Let us suppose we are having a sequence given as like this: x1n, x2n. We have given the equations x1n, x2n. First of all, we have to write the sequence. So what is the value of sequence? When x1n you are finding, so delta n is 1 at n equals to 0, other values are 0, so first value will become 1. Then delta n minus 1 will remain 1, at n equals to 1, other values will become 0. Then delta n minus 2 will remain with minus sign, so it is minus 1. Then delta n minus 3, it means this value corresponding to n equals to 3, this value will be there, so you will again get minus 1. So that's why we are getting this sequence. And in this similar manner, You can see delta n means first value is 1, delta n minus 1 element is missing, so nothing is at n equals to 1. So this value is 0, then again the element is minus 1, then this value is 0, and again the element is minus 1. Now, because we have to apply the circular convolution, so both the sequences must have of equal length. So what we will do? We will add one extra 0. We will add 1 0 and the sequence x1n, so that we are having these sequences like this. So now we can easily solve this. How we will do this? We will, with the help of one sequence, we will make a matrix. Let's say we are making a matrix with the help of x1n. So how these elements will remain? How will we place 1 1 minus 1 minus 1 0? Now what happened? This 0 will comes over here and like this. So 1 is here, 1 is here, minus 1 minus 1. Again this minus 1 comes over here, then 1, then 0, then 1, then 1, then minus 1. This minus 1 will come over here and like this, and again 1 minus 1 minus 1 0 1. Okay, so this is how we have obtained the matrix. And another matrix we will 1 0 minus 1 0 minus 1, and we will simply do the matrix multiplication. When we will do the matrix multiplication, we will simply get the values. Okay, that is nothing but the convolved sequence values. Okay, like here we have seen 1 1 0 minus 1 0, 0 1 1 0 minus 1, and like this. So we will do simply the matrix multiplication. The dimension of this matrix is 5 cross 5, and this is basically 5 cross 1. So the result here is of your 5 cross 1. So you are having matrix elements 3 0 minus 3 minus 2 minus 5. So sorry, 3 0 minus 3 minus 2 2 after the matrix multiplication. So this is your convolved sequence. Okay. It is important to note that if we will see the complexity, it looked like it is a simple question to solve using this method, but this method is not computationally efficient method, because matrix multiplication requires a lot of computations. Okay, so computational complexity is higher in this particular method as compared to the previous method. And let's say come to this third method, that is DFT-IDFT method, or it is also called Stochamp's method. Okay, so we will compute the same question here with the help of DFT-IDFT method, means 1 1 2 2 1 2 3 4, which we have seen here in this case. We will again solve it using DFT-IDFT method. So you know the expression for DFT. What is the expression for DFT? You know the expression of DFT is xk equals to summation n equals to 0 to n minus 1 xn into e to the power minus j 2 pi nk by n, where k equals to 0 to n minus 1. Okay, so this is the expression by which we can obtain this value. Okay, so the algorithm of this particular method is like what you will do. You are having two sequences. First of all, you will get x1k, which is nothing but DFT of x1n. Then you will find the x2k, which is nothing but the DFT of x2n. Then you can calculate the multiplication of x3k, which is nothing but x1k into x2k. Means you are having two matrices, x1k into x2k, and you have to multiply these two matrices element wise. Okay, it is important to note that these two sequences DFT, because in case of circular convolution, both the sequences must have of equal length. So it means you have already made these sequences equal if it is not equal, but here in this case it is equal, so there is no requirement of adding any zeros in it. So that's why the dimension of these two matrices will remain same again, and you will get the x3k matrix. Okay, but you are interested in finding out the circular convolution, so you will x3n, that will become IDFT of x3k. Simply this is the simple algorithm, and it is very easier to solve using machines, this method. means you can say complexity is less here in this case. So first of all, we will calculate x1k for this sequence 1 1 2 2. So this is the expression, you know, which I have already written over here. Now according to this expression, you will calculate the values of x1k, and which comes out to be x1 6 minus 1 plus j 0 minus 1 minus j. So these are the four values that we have obtained from you can say this sequence x1n, which is given as 1 1 2 2. So that finally after computation the values x1k are 6 minus 1 plus j 0 minus 1 minus j. So this is the DFT values for the first sequence x1n. Now for the second sequence x2n, which is equal to 1 2 3 4, we will again compute the DFT, and again this time 4-point DFT need to be solved. So again the values are like 10. Here you can see the values 10 minus 2 plus 2j minus 2 minus 2j. Then you will simply have to find out x3k, which is x1k into x2k, and this is the values that we will obtain. We will correspondingly means how you will get x30. X30 is nothing but x10 x10 into x20. x31 is nothing but the x11 into x21. Okay, and then you can find out x3n by taking the IDFT of these values. So this is nothing but x3k. Now you will put x3n, which is nothing but IDFT of x3k. So this is the formula of IDFT. x3n is equal to 1 upon n summation k equals to 0 to n minus 1 xk into e to the power minus j 2 pi nk by n. So this is the expression, and because x3n, so this is nothing but x3k. Okay, so according to this expression we can find out x30, x31, x32 and x33. So this is the values of x3, 15, 17, 15, 13, and these are the same values that we have obtained using the first method. Okay, so this is how we will solve the circular convolution between two sequences using these three methods which is mentioned here. Okay, now another aspect is linear convolution using circular convolution. Okay, so it is to be noted here that the linear convolution that we will compute is basically, we have already seen the differences, will be computed using circular convolution, because we are studying this particular topic under the unit DFT, and the property of DFT is circular convolution, not the linear convolution. Okay, so how you will do it? Okay, so it is important to note that the resulting sequence obtained by both linear and circular convolution have different values and length. Linear convolution results in an aperiodic sequence, while with the help of circular convolution you will get a sequence which is periodic sequence. So the elements, let's say if we are having two elements, two sequences having length n each, then the value of linear convolution will become 2n minus 1, while the length of the sequence in case of circular convolution, this will become n. So circular convolution will produce the same sequence values as those produced by linear convolution if zeros are padded at the end of two given sequences x1n and x2n. So after zero padding, similar methods, that is graphical, matrix, IDFT, DFT, to obtain linear convolution as well as for circular. It is so here it is to be noted, let us suppose we are having a sequence and we want to calculate this linear convolution. So by padding zeros in that sequence, if we will basically calculate the circular convolution of padded sequence, then we will get the value of linear convolution. Means you can see here, let's say there are two sequences 1 2 4 and another one is 1 and 2. Okay, and we have to find out the linear convolution between these two sequences. So you can see the length of Hn is n1, which is equal to 3, and here it is 2. So the length of the convolved sequence will become n1 plus n2 minus 1, that will become 4. So now if what we will do, if we will make the length of these two sequences equal to 4, if we can make it, and simply we will take the circular convolution between those two sequences which are the new sequences. So the circular convolution of new sequences is nothing but, you can say, that is nothing but that is the value of the linear convolution for the old sequence. Okay. So now here what we have done basically, we will make the length of this sequence hn and xn both is equal to 4. So you can say this hn, let's say you can say new, and xn new. So the length is 1240 and 1200. Okay. Now you will perform the circular convolution of these two sequences, and the result of circular convolution of these two sequences, which are the padded sequences, which are your new sequences, will be equal to the linear convolution of your old sequence. Okay. So now this we have applied here basically. Which method? Matrix multiplication method. You can apply any method. You can solve it using graphical method, you can solve it using DFT, IDFT method, but here we are solving this using circular method. Okay. So in circular method, simply you will write this 1200, then again this element will be like this, you know, this procedure, simple procedure. Okay. And then you will multiply by 1240, and again the matrix multiplication will become, so this value will become 1 plus 0 plus 0 plus 0, this is 1, then 2 plus 2, that will become 4, other elements are zeros, this value is 2 and 2 4, 4 4 4 8, and here is 2 4 8, other values are 0 to 8. So 1488 is the circular convolution of these two new padded sequences, but you can at the same time you can also call this is the linear convolution of these two old sequences. So 1488 is nothing but the value of the linear convolution obtained from these two sequences. Okay. So this is how we will compute the linear convolution with the help of circular convolution. It is important to note that here linear convolution will be solved with the help of circular convolution, not directly, because it is as per our curriculum, it is the part of basically you can say part of DFT, and the property of DFT is linear convolution, circular convolution, not the linear convolution. That's why we'll use this method. Okay. And these are the references that I have taken for preparing this presentation. Thank you.